This is the sort of question you often get at A-level. It will show you a graph, it won't tell you necessarily what its equation is, but it will want to see you sketch 3 other versions of it, effectively. So starting with that one there, let's look at them one at a time. What will happen with that one there? It's got a +6 stuck on the end of it. It is being translated 0,6, yeah, and you would need to write that down. It's a translation of 0,6, okay? And you would need to sketch it. So basically, if it's going through 7, it would now be going through 13. That's the key thing you'd have to write. Next one, mod of that function. Yeah. Just this bottom bit here will go up there. Excuse me. F of mod of the function.
Would that be everything on the outside?
The modulus around the y, would it be like the length of y bits reflected in the y?
We're getting close. Something is reflected in the y-axis.
The bit on that side.
Which side?
The left side.
This side over here will go over here?
Yeah.
No.
Oh.
Okay? Because what they're saying is here, where f used to be -5, we're now going to have f of 5 instead. So that bit of curve will disappear, and that curve over here will appear over here.
Really?
That's a bit
Why?
weird.
Because if we look at, well, think, if x was -5, if x is -5, what's mod of x?
5.
5. So instead of where x was -5, we used to have that, we will now have what happens at f of 5 instead,
Oh, that makes sense.
which is what happens over here. So all of this side will end up being reflected over here. So if we look at those, f of +6, there we go, shifted up 6. The mod of the whole thing, that bit just gets flipped up. And mod of x, what happened on the right now happens on the left as well. The old left-hand side has just been removed. Okay? So that was that one. Right, next one. Let's have some bits of paper here. There we go. There's your starting function. What will this one here look like? Mod of f of x. What change will we see? Sunny?
What will get reflected?
Yeah. That anything below the axis, the x-axis will go up there. So instead of coming down here, you then have something shooting up there. This one here, what's this -1 on the f mean?
Inverse function.
Inverse function, which is a word that Ollie used earlier. Not Ollie, sorry, Sam used earlier. But you didn't use it correctly at the time, which is why I asked you at the time. I said, I reckon you know what you mean. What is the inverse function?
1 over the function.
Not, no, that would be the reciprocal.
Oh, yeah.
Reflected in y equals x.
It is. The inverse function is reflected in the line y equals x. Okay? So, what I've written up here, if you started with y equals x squared, to find the inverse function, f of -1, if you swap your x's and y's over, you should have done this at some point when you did a chapter on functions. Swap the x's and y's over, you get that. Instead of y equals x squared, you get x equals y squared. Then rearrange it until this new version is y equals. So if you rearrange that to make y the subject, you get that. So it is the reflection of the line y equals x, and it will also be that graph. Y is the square root of x, if you were starting with x squared. So that's another way of doing it. We'll look at that one in a minute. This one here, half f of 3 of x. That's two things done together. What will the effect of the 3 in there be, first of all? Yeah, so for the benefit of the tape, so yeah, pushing it in from both sides, so everything is a third of the distance from the y-axis. And then the half here. Yeah, Laura's doing it right. Half the height it was as well. So if we look at those three, here we go. The first one, everything that's below the axis has got reflected above it. The inverse one, it is a reflection of the line y equals x. The line y equals x would have gone there. And if you reflected the top one in that line, you would have got that. This one over here, the 3 here has pushed it in. So what used to occur at 2 here, where across the x-axis, now happens at a third of 2. So that now happens at 2/3. and everything is now half the height. So instead of crossing here at -2, it will now cross at -1. So often they will ask you to, give the coordinates of points where it crosses axes and things like that. Okay. Right, next question. Describe a sequence of 2 transformations that will map that one onto that one. How can you get from there to there in 2 steps? What would the first step be? Yeah. The first step is that -2 there, which shifts it like that. How do you say that in proper maths language? Translation. 2, 0. Okay? Then what's happened? Stretch of 9
Parallel to the
to the y-axis. Yeah, that's right. Okay. So there we go. That was just a mark scheme for that one. Actually, they did say vertical stretch. Sometimes they do say parallel to. So either seems to be okay. Right. Next question. How can you get from there to there? A stretch of 1/3 parallel to the x-axis. Yes, that's pushing it in. Yeah, and then.
translation.
Yeah, because think of a 10 at the beginning, could be like a +10 at the end. So yeah, horizontal stretch, scale factor of 1/3, that's like the pushing it in bit. And then the +10 is the translating it up 10. Okay, next question. Can you actually have a go at doing this one on a bit of paper? Okay. There's your starting graph. Those are the 3 you've got to come up with, okay? So can you just have a go at yourself, just sketching those 3 a minute, and I'll pause the video at this point.